Okay, so continuing what we had been doing in the morning with ship types. So, ship types, we have seen various types of ships, both inland and ocean going, and then there are some of the, we will talk a little about the other component, that is the offshore structures, right. Offshore structures, essentially they we can see that the advent of offshore structures started sometime from 70s, early 70s, right, for oil exploration, offshore oil exploration, right. So, at that time, I mean until mid 70s, the offshore structures used to be primarily only in the fields where the depth of water is less, at the lesser depth. Now, as time is going on, people are exploring all the oil out and further going in the deeper and deeper oil fields, right. Today, it is feasible to take oil from a depth of around 3000 meters, right, that kind of depth. Anyway, so with that, the offshore structures have also evolved over the years. We had, I mean this, so they are essentially classified in the following types. One is what is referred to as bottom supported platforms. Bottom supported platforms. And another one is floating platforms. Okay. So, the fundamental difference, floating platforms, right. Bottom supported ones means which are supported, which are sitting on the seabed, so called seabed, and the floating platforms, they are floating. So, obviously, the bottom supported ones are the ones which are the shallow depth ones, which could be used only for a shallow depth, right. So, of these bottom supported, we had various types. They are referred to as fixed platform, right. Another one is gravity platforms, and there is another type which is referred to as compliant tower. Fixed, gravity and compliant tower, right. So, fixed platform, by the name only, it's they are generally used to be of used to have a so called a substructure and a platform. Substructure means structure below the water, and a platform, and the platform can be the simplest ones are with one or two platforms, and the more complicated, or so to say integrated ones with several decks with all kinds of drilling and exploration so called machineries, right, because it will depend on what purpose this offshore structure is being used. It can be for exploration, it can be for exploitation, it can be for many other so called requirements. So, anyway, that is how the fixed towers, the things were like that it is fixed in the seabed. That means, the legs are grouted in the seabed, right. That means, once the tower is, it is taken to the site and it is literally fixed, cemented to the seabed. So, that is how they are the fixed towers, and obviously, they are generally very shallow depth, right. The shallow depth order of depth were of the order of 15 meter, 20 meter, like that. And then came the things which were referred to as gravity platforms. Gravity platforms means they are also heavy structures and they used to sit on the, the very function of the gravity platform is that this sit on the seabed of its own weight. That means there no foundation work is done, right? No foundation. In the fixed platform there was a foundation work. Maybe you can sit that side because you won't be able to see there. Probably you can sit that side because that screen is working. So the difference between fixed and gravity is fixed is bottom foundation was done, whereas in gravity platform it only sits of its own gravitational force, right? So obviously that makes the calls for a requirement of a heaviness of the structure, right? Many a time the legs are of concrete, right? And also another requirement of this gravity platform is that it needs a fairly so-called strong and subsoil conditions, right? If the subsoil is very loose, then as you put a structure, it will keep on sinking. So that is also another requirement. That means you have to study the subsoil conditions that should have the necessary bearing capacity, load bearing capacity, such that it can sustain the weight of the gravity platform and it sits in the desired location. So that is what is gravity platform and the fixed platform. The advantage of these two types are obviously that they are, one can say, rock steady, means they don't move with the waves, right? So that your operational aspects becomes very easy, because if you want to do a drilling operation, your all the drill equipment should go vertically down. So there is least bending moments or the forces will act in the drilling equipment, whatever is going down. Similarly, if you are exploring oil, the pipes, riser pipes also will have minimum forces. So design of those things become easy, but it has the inherent disadvantage that you cannot make these for a depth of 1000 meter or 5000 meter or whatever. Even for 100 meters is not feasible. So very shallow depth operation, these are feasible. So gradually people looked, as I said, in deeper and deeper seas. So there came the concept of compliant tower. Compliant tower, schematically it is something like this. Schematic, the whole idea of compliant tower, right? There is also a bottom supported platform which is referred to as, sorry, I have compliant. There is one N, I am writing this side. Compliant tower, that means it complies with the waves. As I said, the fixed and gravity platforms, they are steady. That means the waves will come and hit on it. So as on one hand we have advantage of it's being rock steady, your all the drilling accessories, for pumping the oil, the riser accessories, there the moments are less, but there is a heavy moment in the overall structure because it cannot move, it is fixed, right? And also the disadvantage of it cannot go down to a bigger depth. So came the idea of compliant tower, which has that freedom of movement with the waves. That means, as if you imagine it can sway like this with the wave, as if the whole structure is hinged at the bottom, and it is so. So it is something in between a fixed structure and a floating structure. Floating structure is totally free to move around, right? It can move in all directions as well as vertically if it is not properly restrained. A fixed structure is static, absolutely fixed. But if I restrain the vertical movement, then one structure has a freedom of movement in the horizontal plane. That means a swaying movement, right? In this plane or whatever, means in the horizontal plane a swaying movement. So compliant tower was conceived, that is, schematically it would look something like this. Suppose this is my sea level, water level. This is a structure, right? A tower like structure, okay? A tower like structure which is hinged at the seabed. It is hinged at the seabed, so it has a freedom of movement as the hinge has been drawn in that fashion, in this direction only, right? It can sway, right? This movement is called sway. That means in this way the whole structure has been made lighter. The whole thing is the entire platform or the platforms, the decks, because these are the decks. Those decks will house the required machinery, equipment, etc. So that is mounted over a tower, and the tower you can make it much longer, much taller, so that you can go to a greater depth, and it is hinged at the bottom so that it has a freedom of movement. This is very schematically drawn. Yes.
What exactly is that hinge? How is it?
It's a hinge. Hinge means, it's a literally an hinge. I mean, how do I we can explain in this fashion. Suppose you have there is a, say, imagine a shaft over which you have this is one part connected to a, say, the central part is connected to the this. If you look from this angle, this side, you have the shaft in between, or the pin, hinge pin, and then you have this is outside, this is this outside small cylinder. This in, it is free to rotate about the pin. This is my hinge pin, right? So to it I have connected, welded the entire tower, say. This will be a huge one, right? So it is connected to this so that it can rotate about the pin, right? And then you have other, and this one is grouted at the seabed. So either the pin is rigid, connected, clamped to the seabed, and over this cylindrical stuff, the middle part moves, or the pin is rigid to the cylindrical stuff and these two bearings are free to rotate. It's simple hinges. The very miniature version of these are the hinge as you see in the door. The door rotates. So that kind of hinge. This is very schematically and in a very simplistic way. They are definitely not that simple, because if it is free to rotate, you may ask why not it does fall down. So those restrictions are there. Like even in door hinge, there are certain hinges, it opens only up to this much. It doesn't open up 180 degree. It's that way, right? So obviously that is beyond our scope of how the engineering and design of that hinge is. We will not go in that detail. We are here only talking about the concept, right? That is how. And our area of purview is essentially the tower structure, the deck structure, which in the morning I was telling that they are essentially the same way as we do for ships. Same thing will be for this offshore also. Here we are just taking a look at what are the different types of these offshore structures. Anyway, so that is how this compliant tower concept came, and by simply doing this, one could go up to a depth of around 1000 meters, almost 1000 meters. That means that was a big leap towards offshore oil exploration, just by making this concept of compliant tower. Still further requirement of further depth, then came the concept of floating platforms. So, the moment it became floating platform, it became absolutely free. You can be at, I mean, then you do not have any restrictions of what the subsoil condition is. You do not, virtually do not have the restriction of what depth you are going to operate in, right. So, in the floating platforms, we have two types. One is referred to as tension leg platform, tension leg. Another is floating production system, or also floating production system, tension leg platform. In short, they are more universally known as TLPs, right. TLP is nothing but tension leg platform. So, what is happening in this tension leg platform is, this platform is a floating structure, means that entire superstructure, the superstructure is your so called decks, right. Various decks will be there, over which you have, well, you will have accommodation also, right. You have all kinds of machineries and whatnot, right. It will be a very heavily equipped sort of place, right. And this will be supported on some kind of floating submersible, some body which is floating, right. So, now what happens if it remains just like this, then obviously your, I mean, it will keep on drifting in the sea, that you cannot have. You will have to have one particular location it is located, right. So, that is what is done by the tension legs. That means, it has a mechanism of connecting to the, suppose I am just schematically drawing as if 3 tension legs. This is my sea bottom, right. These are the tendons, they are referred to as tendon. So, what is done is, as if you tie the vessel, tie the entire I mean the offshore platform, the floating platform, with ropes down at the seabed. That means, at the seabed you have the necessary tying arrangement, or so to say hooks are grouted in the seabed, to that you tie it, right. And then this has a this will have a positive buoyancy. Positive buoyancy means, what is happening? I am pulling the thing. It is something like in a bucket of water, you take a tumbler and try to press it down. So, you feel a upward thrust, is not it? If you just leave that tumbler in a bucket of water, the tumbler will float. You put some water in that, it will sink a little, but it will float nicely. But with that amount, you try to press it down below further. So, what happens? You feel a upward thrust, right. Same thing, you think that instead of pressing it down, I try to pull it down. So, that is what is done here. It is pulled down, that means these tendons are in tension. Why? Because when you are pulling it down, it has a buoyancy. So, it tries to float up, that means the upward thrust automatically works. That is what is a positive buoyancy, right. You understand, right. So, in the process what happens, there is a tension in these tendons. That is why they call tension leg platform. Why these tendons are kept in under tension? What is the reason? Why it is so? It could have been neutral, isn't it? But it's kept in tension. The reason is so that to minimize the swaying motion, minimize the heaving motion. This motion, if this is my z axis, the motion along the z axis is called heaving motion, right? In the xy plane, the motion is sway. Because you see, the worst kind of motion is the heaving motion for the function it's going to serve, because it's going to drill it. And what is the drilling operation? You one after another lengths of drilling, well, if I call it drill bit, has to be, you'll have to go and connect it, right, because it will go down to thousands of meters. Or if you want to pump the oil, you have to drop pipes, right. So, if there is a heaving motion, then what happens? I have a drill bit, so it goes on like this, you have difficulty in doing the drilling operation. Whereas, when you have a very long length, then if it moves like this little bit, it can withstand that. But if it goes up and down, then it becomes a problem. So, to minimize the heaving motion, these tendons or these ropes or these legs, flexible legs, are kept under tension, right. That is the concept. And here, so thereby your heaving motion are minimized, and as well as the deployment of tendons are done in such a fashion that your swaying is also within a permissible limit, because you cannot allow to sway it kilometers, definitely not, right. Within few, whatever is the permissible movement is possible, it's limited. So, that is what is essentially the tension leg platforms. And here you have, well, yeah, it can walk, I mean, the technology as of today, that it can go down up to almost 3000 meter water depth. It can be installed in such deep offshore oils for production of this what do you call crude, right. So, here the biggest challenge as such is fixing the bottom seabed connections. Making the seabed connections are the major challenge, because the other things have become very easy. It's just like a ship kind of a thing, a floating thing, and over that it's all steel structure, decks fitted with necessary equipment. So, biggest challenge is actually connecting the bottom, those so called clamps, wherein or the fixtures wherein you are going to clamp the tendons. So, that is what is TLP. And then next we talked about FPS. FPS is floating production system is called, and when we talk about FPSO, then it is floating production, storage and operation. So, these days this particular concept has become very popular. Floating production, storage and operation, right, FPSO. In all the previous offshore platform types, what we have seen, one thing you can see that all of them are location specific. They are fixed to the location. That means, when we are talking about the fixed platforms, well, it is literally fixed. There is no way you can move it. When you talk about gravity platform, though it is not fixed, but for all practical purposes it is fixed. Once you sort of install a gravity platform in one place, now when that oil gets dried up, you are not going to remove that platform from there, because it will be huge job and totally unnecessary. But in the process, what is happening? You are abandoning the entire structure. You cannot use it elsewhere. Similarly, with compliant tower, it is difficult to unlock and take it elsewhere and put it. Same thing with probably tension leg platforms, but to some extent tension leg platforms, part of it can be recovered. That means you cut the tendons, float it out elsewhere, again connect new tendons. So that becomes versatile. And FPSO is fully versatile. It is basically a ship, a production platform mounted on a ship. So it has its own propulsion power. It can go to a oil field, do the oil exploration operation till you get oil. The day you do not get and you have stuck oil elsewhere, the vessel moves to the new location. So that way, that's how this FPSO has become very now sort of that way popular, one can say, because the other ones, well, if one does a cost comparison, not necessarily FPSO will be cheaper compared to the other ones. Fixed platform will be a cheaper option. Obviously, they have other disadvantage, of course, but for a shallow depth also you can use FPSO. There is no bar against that, sort of, right? Because there is another problem coming up, means from the environment point of view, decommissioning of these offshore platforms. Like you commission, you will have to have a sort of a chalked out plan of decommissioning it, because they are becoming potential environmental hazards. So these days, if you want to install a gravity platform or a fixed platform or any such thing, you will have to show that how you are going to decommission it, so that it does not cause any so called ecological disorder or environmental pollution and disorder, right. But if you have a FPSO, that problem is not there. There is no question of decommissioning as such. When the life of the FPSO is over, okay, you decommission it the way the ships are decommissioned, means you take it on shore and break it in pieces and whatever. You do not abandon it at sea. So that is also an added advantage as far as FPSO is concerned. So FPSOs are essentially floating vessels, ships, and what many people are doing is, instead of building a new vessel, they are converting the old tankers, converting the huge tankers, because there are very huge oil tankers. Very huge means of the capacity of the biggest tankers were built, or around 400,000 tons dead weight, roughly 500,000 ton capacity, right. So similar such huge tankers, not necessarily this 400,000 ton only, depending on the requirement. Many of the old tankers have been converted to FPSO, because here you need storage. It becomes, because when you are using all the other offshore platforms, you will have to have a mechanism of pumping the oil and delivering it. It is not only you will be pumping, delivering. All the previous options do not have any storage facility. That means either you will have to have a side by side a crude carrier standby, wherein in the hold you will take the liquid, it goes that way. And in case of FPSO, the vessel itself has its storage facility. So immediate storing is done, and then from there it is dispatched. Not necessarily the vessel will go and dispatch the liquid, that also it can do, but it can be immediate storage is possible, because it has the huge tanks already there, because the tanker has been converted. right. So, that is what that means, this converting a tanker for this purpose is a low cost option. I mean, if one has to build a new FPSO, instead of building a new one, converting a tanker becomes a easier and more profitable option, right. So, that is what is the FPSO. So, it is a self-contained unit and it can be operated in any oil field without any infrastructure, right, because it itself has everything. So, you do not need any additional infrastructure of storage of that crude or whatever. Here the crude pumping is done through so called risers. That means the vessel is there, it is generally right. Schematically I am showing. So, here you have your conventional accommodation on one side, accommodation of the crew this side, and here you have all the gadgetaries for your offshore operations. And well, this is a huge vessel, it has several chambers wherein these holds can be used for storage, right. So, this is your wherever it is floating, and from here the riser, they are called risers, right. There can be 1, 2 or multiple riser. These are pipes, flexible pipes which are referred to as riser. They are connected to the wells. These are the wells below the seabed. So, here again the challenge is, that means when you explore you find out a possible so called pumping site wherein you can you will get the crude oil, you have to make these subsea arrangements, right. That means those well heads, here the so called well head are to be installed. It is something like similar to that of, suppose you have a like say a pipeline is going, you want to tap water from that. So, you have to have a connection there, and from that to your house you connect the entire plumbing work you do, and you connect that to the main pipeline which is delivering the water supply to all houses, it is connected. So, that is the connection head. Similarly, this is the well, will have some kind of well head, some kind of connection wherein the pipe will come and will be locked there. So, well, as far as this vessel is concerned, I would say that is not the difficult aspect of it, means that is again the same as that of building a big ship. Whatever technology is there, it is good enough, with that one can build the entire thing. But probably the more challenging technology is making these wellheads, connecting these risers to the wellhead, because these risers will be there, you will have to, how do you connect? Somebody will have to go below and physically connect, because if you just drop the pipe, it will not go and fix here, right. So, those are actually the technologies. And also other thing is, now what happens, this FPSO is totally free. So, construction wise, I mean there is no bending moment problem. In all the other things, there was some movement of the structure, right, all those problems were there. Here it is only for exploration, you are only pumping oil. So, these pipes risers are flexible, right, but still it has to have some kind of means of anchorage, some means of position keeping, such that it does not move out, does not sway out too much. If it heaves with the wave, no problem, because the pipes are flexible, you have enough length to take care of that. Right. So, in other words, I mean, as we see, for oil exploration, FPSO is a very convenient one, which gives you all the flexibility and flexibility of depth. As we said that this FPSOs also can be, I mean, virtually to any depth it can work, provided you have the arrangements for the wellheads and connecting to the wellhead, right. So, that is what. So, this is in brief about the various types of your offshore platforms, offshore structures. Now, as you can see, in all the cases, the offshore structures, as far as the structure is concerned, they are nothing but, well, something similar to the ships. As far as construction is concerned, as far as structural components are concerned, offshore platforms are primarily comprising of flat decks, several decks over which you will install the machineries. Only in case of well, TLP, you will have a floating submersible. In case of FPSO, you will have a basically a hull, a ship hull, right. So, that is what about the types of ships and offshore structures. Now, we come to the so next I thought of telling you about. So, now that we have seen what all the kinds of products we will be dealing with, so take a look at the type of industry which delivers these kinds of product. Industry means the shipyard. So, what are the very specific characteristics of this shipyard, right? If I what is so specific about it? Because till now we have seen, because what I feel that before one embarks in designing or working on a product, one should have a good idea of the product itself. If it is an innovative product, then also one should have a innovative idea, that means so called artistic impression, because the engineer will basically engineer the product. So, what he is going to engineer, he should have some idea of it, you know. It is not like a blind chase that you do not know what you are going to hit at the end of the chase. It is not that. It is a very concerted, conscious chase, because I know my end product. I know what characteristics it should have, what functionality it should have, how it should behave, how it should respond. All those things are known. Known means those are the requirements. That is what I want. I want to design a car which will look beautiful. Well, that is a characteristics, requirement. So, the engineer will work towards that. Okay. So, that is why our first lecture we tried to look into what all types of products are there. Now, we will take a look back to the industry where these products are made, if there is anything specific about it, right, any specific character. Because these products, that means the ships or offshore structures, they are also so called industrial product, right. So, if we systematically see, first and foremost it comes to our mind is the product size, right. No other industrial product has this huge a size. You think of it, because the sizes can be the super tanker, I mean the FPSO we are talking about, or even a middle sized bulk carrier, say of capacity of 100,000 tons. The length of the vessel could be, well, somewhere of the order of 250 meters. You can imagine 250 meters. So, that means what I mean to say, this industry should be such that it should be able to handle a product of this size, right. So, first and foremost is the product size. The moment the product size is such huge, immediately comes the man-hour requirement for the production, man-hour requirement. Why man-hour requirement is important? That means it is the involvement of number of workers and the period of production, right. If say for example, as you may have heard that a car is produced in every minute, what does that mean? It means that every minute a car comes out of the production plant, but the seeds have been sown probably, God knows, maybe 6 months earlier. Actual production time could be 6 months for a car, right. But for a ship, say of this size, 250 meter long, the actual production time could be 3 years. From the day 1 to the delivery of the vessel, maybe 3 years. So, that is a long period. The moment it becomes a long period, there are many uncertainties creep in. You do not know what the steel prices or some equipment price will be after 2 years. You do not know what sudden political change may take place in the country or elsewhere, because this industry is not an industry which will only source everything from within the country. You will have to depend on many other things. So, that time can make a difference in the entire process of production. So, that is how the man hour. Then, well, next one would be wide variety of materials that is being used. Like I said, I mean, even a so-called cargo ship, general cargo ship, well, the main material of construction would be steel, but there you will have a accommodation region where the officers and the crew will stay. So, there you will have to give a proper facility, proper comfort. So, starting from simple, I mean, good furniture to good window curtain, everything will come. So, wide variety of materials, that immediately calls for wide variety of skilled trades, wide variety of workers, various trades. That means people of various trades will have to work in unison. They will have to be, I mean, proper cooperation should be there. Next, one of the more important thing, all these things, manpower, material, trades, well, similar situation you may find in some other product, industrial product also, say automobile, car or a aircraft or a locomotive or the railway coaches. You may have somewhat similar, though the manpower requirement is of not that order. However, material and trades can be there, because in a railway coach also you need a welder as well as you need a good carpenter, and also need a good upholstery person who will fix the cushion and all that, right. Next, very typical of this shipbuilding industry is, it can be mentioned like this, it is a case of unit production. What does that mean, unit production? That means here we do not have a mass production, a scenario of mass production. In any other engineering product, be it a computer or a television set or a aircraft even, they are generally a case of mass production. I am saying generally because I have included the aircraft in the list also. If I delete the aircraft and put automobile, it is a mass production, 100% mass production. So, what is the fundamental difference? Fundamental difference is, then you design the thing, test it thoroughly, and then the design is frozen. Then you just go on producing. So, you have all kinds of production advantages. What advantage? Say you will produce 1 million cars of one particular design. That means the car body, for example. So, you can as well have proper matched die plate bending machine having matched die, through which you bend the plates to get the shape of the bonnet, of the door, etc. They are expensive, those making those matched die, but the expense it is well justified because you will be producing 1 million such pieces. In ships, you cannot make any such match die because probably you will be building 5 of the identical types. The series here is of that order, 3, 5, 10, right. If it is a smaller vessel, say fishing, we have not talked about fishing trawler in our classification. Anyway, say a tug, right, or fishing trawler, there might be the requirement of 50 fishing trawlers of identical size, identical design, but 50. That's nothing in comparison to tens of thousands or millions, right. So, it's more of a case of a unit production. That means, you do not have that benefits, advantages of mass production. And also another aspect is that it is even if it has a, you may hear of a series production, that means like I said, say a bulk carrier, some particular cargo operator places an order for 5 identical bulk carrier of 60,000 ton each. Now, what happens is, when first bulk carrier you start building, when the designs are done, so you start the manufacture of the bulk carrier, then after a few months you start the second one, this progresses simultaneously, again after a few months you start the third one. By that time possibly the first one is delivered, second one continues, third one further continues, and the fourth one you start, and so on and so forth. So, this period could be anywhere between 2 to 3 years. Right. So, what happens? Some material needed at this stage will be required for the second vessel at this stage, for the third vessel at this stage, and so on. So, the requirement of these product, when first it is needed, say on particular date, the next one will be needed probably after 6 months or 3 months. I mean, that is the thing. In a car, the car door will be needed every minute. If the production rate is every minute a car coming out of the production line, that almost means, almost may not be every minute, but every probably half an hour a door will be needed. So, I can have a production setup for the doors which will go on stamping out the doors, but here firstly I need only 5 of them, the identical piece. So, that 5 if I produce today, the last one will be used after 15 years probably. So, what is the use of keeping that? Firstly, it will be storage will be problem, it will get damaged, and then the money I am blocking in that. So, the advantage of series production is also lost. Only advantage is there, well, some of the design things are, preliminary design is fixed, but what happens when the first one is delivered, you will have feedbacks from the owner, then he will say change this, change that. So, some of the modifications will keep going on. That means, it is not that the design job is over once the first one is delivered or production has started. So, you do not have the benefits of series production, right. It is a case of unit production and no benefit of series production. This is no benefit, which in other industry you have. Take for television industry or automobile industry, locomotive industry, even aircraft. Aircraft, the series are small, but their design is done, means done. Only minor changes of seat arrangement. Somebody may say I want 18 rows, somebody may say I want 19 rows, that is all, right. Rest all remains more or less same, right. So, here it is a, that is how one says that it is not a showcase product. Aircraft also you showcase it. In the aircraft shows, the companies, the Boeing or McDonnell Douglas or whatever, they showcase their product. Automobile, they showcase their product. You have to choose from whatever is available. You do not say that I want this. Here, the customer says, I want this, right? Customer puts forward the requirement and you'll have to comply to that. The one who can best comply, he gets the order. So, it's that way a kind of a competitive industry, and you'll have to comply to the customer's requirement. So, that's how the next thing comes is the capacity and speed. We are talking about ships. So, in ships, these are the two fundamental things a customer will ask for. He will say, I want to carry 10,000 tons of cargo at a speed of 14 knots. His requirement is only this. He will say only these two parameters. At best, he may say, okay, my route of operation will be from Madras to Sydney. That's all. So, based on these three operations, you have to develop the entire product. So, what is most important? That you will have to satisfy at the end of the day, when this is delivered, it should be able to carry 10,000 tons of cargo safely. That is the capacity you guarantee, and also should deliver that 14 knot speed. That is very important, because all these you are telling at the very preliminary stage, when you have very preliminary sketchy idea of the product. You have not done any detailing of it, because at that stage only you will have to say, and that is the tendering stage. Then whoever gets the order, then only he will start working in detail. So, with those sketchy, scanty information, you should be able to predict the speed, or you should be able to quote. That means next comes is the cost. Cost is huge. You will be able to predict the cost of the product, the delivery period, you should be able to foresee that, well, within this period I will be able to deliver it, and the cost incurred will be so much, and the speed delivered will be as the customer wants. All this based on very sketchy information. If you fail to do that, you lose. You have to pay penalty, because speed you will have to show. Unlike your car, there the meter shows 180, but you will never in your life probably drive in 180. So, there is nothing to worry about. You will be shocked to learn that we bought a new Maruti Esteem engine. We had some requirement of around 50 horsepower. So, we thought that Maruti Esteem engine will work very nicely, because they claim it delivers 57 horsepower. So, when we put that, it was not, the vessel is not functioning properly. What's going wrong? So, we took the machine, put it in a test bed, and found that it's delivering only 17 horsepower. I don't know what is wrong. This is how, if Maruti is cheating us, I don't know. Only 17, 17. But probably 17 horsepower is enough to push the car at a speed of 100 kmph, and that's fine. Because you will not be driving at 180 kmph. Neither Maruti Esteem has said that you can drive at 180 kmph, right? Anyway, so these are the very typical things of this particular industry. Well, and as I said, the delivery period, that means the delivery schedule. When you say that I will deliver by after say 36 months, 3 years, you will have to deliver at that time. You fail to deliver, you will have demurrage clause. You have to pay to the customer penalty, isn't it, to the client. And if you are on a very safer side and you calculate and you say, okay, I will deliver after 48 months, then you may not get the job, because your competitor may say, I will deliver in 40 months. So, in a spree to get the job, if you say I will deliver in 39 months, you get the job and you cannot. So, not only you lose penalty, you lose credibility. It is a very, very competitive market. You lose credibility. Next time a ship owner will not come to you, right. So, that is delivery schedule and cost. Then, well, exact evaluation of man hour. We have talked about it requires huge man hour. Now, the question is evaluation of man hour. Why that is needed? Because evaluation of man hour requirement means because you need this data. Once you have this data, then you can form a data bank based on which you quote for the next I mean your newer jobs. Because how do you say, suppose you have built a vessel of 12,000 ton capacity. Now, you have a tender inquiry of 20,000 ton capacity. You have to design afresh. You have not built that. But how do you then predict that, well, I will take 29 months to build this based on your past data? That means, this evaluation of man hour if you can do perfectly, then you know, okay, so much of welding takes so much of time, so much of piping work this time, electrical work, all kinds of work, right. So, that is easy to say, but that is what we are saying, that here in this type of industry, it is difficult to evaluate this. I am not saying it is not possible, but it is difficult. That means, to keep track, one particular job is being done. Here they say this pen is being manufactured, one can, in the manufacturing this thing, whoever is manufacturing it, he can precisely say that what is the time taken to produce one pen. But to precisely say what is the time taken to produce one particular steel panel, a particular component, structural component of a particular ship, it is not very easy, because the work starts, it will wait for some time, again some work will be done, again some remedial work will be done. Depending on how much remedial work is being necessary, it is necessary in this panel so much, the next panel may be less, and so on and so forth, very complicated, right. So, these are the typical features, and finally, I would say that the coordination of activities, ultimately it becomes a huge management problem, I mean a management issue I would rather say, because you will be not only dealing with huge workforce, you are dealing with huge amount of materials, dealing with huge high volume of materials, high cost of materials, right. So, all these things, management of all these items, the procurement scheduling, the indenting procedure. If you do not procure in time, your work will get stuck. If you procure too much in advance, then unnecessarily you are blocking the money, blocking the space in the store, chances of damage to the product, that component. So, it is overall a real management challenge also at the same time. So, that is what is the shipbuilding industry. That is how we see that it has a very specific character in comparison to all other manufacturing industries, where things are different for that basic fact that here the products are huge and production size, the volume of production per unit is very less. That means, same product only 1, 2, 10, 50 maximum, right. Okay, so we stop here today. We will go over to the next.